Thank you for tuning in. This is Orbit LT, Overview and Training. In this brief training video, we're actually going to have two sections. First is just the keys for a laser measurement application. And then second is setting up the laser with the Orbit Network. This will include powering the laser as well as connecting to software or other equipment. Now, just to give a brief overview, this Orbit LT laser is a calibrated laser sensor for orbit. It is also very compact, just 20 millimeters wide by 46 millimeters long. Also, this is a sensor that will identify on an orbit stack just like any other contact probe or other module on the Orbit Network. So this is something where you could actually stack orbit probes along with Orbit LT lasers on the same network. Now, before we discuss connecting it to orbit, we thought it might be good to just have some laser triangulation basics, as this is a different approach from using contact probes. First, we're just going to review the key components in a laser triangulation sensor. First, of course, is the laser emitter, and that, of course, projects the beam. Then, a second key component in there is what's called a CCD, or a charged coupled device, and this is what actually receives a beam back into the unit. Now, basically, how this works is the laser is projected onto a surface, like what you see there. Then a portion of it was reflected back into the unit onto the CCD device. Now, as you can see, as the surface moves further away or comes closer, the return beam comes into a different portion of the CCD. Now, basically, the position of that light point on the CCD is correlated to a distance, and that's how the distance is measured. Now, for this type of technology, there are some application recommendations. First, we're going to discuss surface. Laser triangulation requires what's called a diffuse surface. So this is where if a beam is projected onto the surface, it's going to have a diffuse reflection where it reflects everywhere. So an example of a diffuse surface would be if you projected a beam onto a wall or onto a regular table. Now, if you project the beam onto a reflective or what's called a specular surface, the beam will actually reflect back to the emitter, and actually you will likely not get a reading on the CCD, thus no distance measurement. Laser triangulation is not ideal on a mirrored surface. The same goes for glass. Typically, especially if the glass has no type of reflective properties, the beam will pass through it, and again, you won't attain a reading. One thing you can possibly do, and you can work with a Solartron engineer on this, is actually use a laser for what's called a specular mode, where you actually tilt the surface. But an alternative would be actually to use Solartron feather touch probes and ultra feather touch probes, as these are often used to check glass in the automotive industry and electronics industries. Another key factor is environment. The measurement surface that you are checking must be free of oil and moisture. See, if you have perhaps oil on the surface, the beam will actually reflect off of that oil as opposed to the surface itself, and that can affect the reading. Particles in the air can affect the performance as well. Another thing that should be noted is that the face of the laser must also be kept clean. If there's moisture on the face of the laser or perhaps some oil, that can actually refract the beams that are coming in and out of the unit and thus affect your reading. Now again, if the environment is too dirty and it's not possible to measure with a clean surface, you can actually consider contact probes. We actually have both IP65 and IP68 sealed probes available. Another key factor is surface geometry. One thing for sure is you want to make sure that the return beam is not blocked in any way, such as what you see there. So that's key. You want to be careful if you are checking inside a bore or checking inside a slot. Now, if you are checking the slots, make sure the laser is actually parallel to the slot being measured, like what you see there. That way you will get an effective return beam. In addition, for moving surfaces, like what you see here, make sure the laser is perpendicular to the direction. If you are checking, say, the top of a cylinder, make sure that the laser is actually parallel to the axis of the cylinder. Or if you are checking, say, something on a conveyor or a moving surface like that, make sure again that the laser is perpendicular to the direction of the moving surface. Now again, for any application testing, please contact your local Solartron representative before acquiring a unit. Now on for our next section, setting up the laser with Orbit. Now first off, when mounting the laser, you can use two M3 screws, which will thread right into the housing. Or you can use two M2 screws, feed them through the laser, and then buckle them down with two bolts. It should also be noted too that we recommend that the laser be perfectly level with the surface you are trying to measure. Otherwise, you may have inaccurate readings. Now, powering the lasers with Orbit actually takes a unique setup. That is because gauging probes require just 5 volts of DC. Also, the Orbit module requires just 5 volts of DC. However, the Orbit lasers require 24 volts of DC. So how do you run both? Well, on the Orbit connection, 2 pins run 5 volts for the modules and the probes, and then a third pin runs 24 volts for the lasers. Thus, both types of sensors can be run on the same network. So now when you add a power supply interface module, there's actually special PSIMs that can power both. So you have what's called an AC PSIM /24/5. So this has a power input of 120 volts to 340 volts AC, basically typically what you can plug into a wall. And this will power up to 31 probes and modules and power up to 20 lasers. Please use the PSIM power calculator on the Orbit support pack to see how many power supplies you will require. Then you also have a DC PSIM /24/5, and this has an input of 10 to 30 volts DC. And this will again power up to 31 probes or modules and power up to 20 lasers. Now also, if you are using the Protocol Interface Module, or PIM, that will actually power both lasers and probes up to 10 units. Again, refer to the power calculator because you might need to add a PSIM if you are using large numbers of both. Another thing too is we actually have a special AC PSIM /24. Again, this is one where the PSIM can plug, into just a wall outlet, but this does not power modules or probes. This is actually used with like a USB interface module for smaller applications. It's actually lower cost. Now this is an example of a USB interface module and an auxiliary PSIM running a laser with Orbit GCS. One recommendation, make sure that you power up the power supply interface module first. Otherwise, the laser will not be properly powered and you will see a solid red LED like what you see there. If this occurs, make sure you unplug everything and then just restart. When the power supply interface module has a proper power source, you will see a green light like what you see there. Then everything in the Orbit stack will function normally. Now we are just going to briefly review the function of the LEDs that you see on top of the laser unit. Now if the output LED is flashing red, that means the laser has no external communication yet. Once it turns green like what you see there, that means a USB has been plugged in, or perhaps the Ethernet or the protocol interface module. Now next up is the state LED, which describes the status of the laser. Now if it is switched off and the laser is still being powered, that means the beam itself has been switched off by an external computer command. We will discuss that more in a second. Now when this beam is on but it's flashing red, that means one of two things. Either it's out of range or there's some type of error with the unit. Now when the LED flashes green, that means a reading is being taken within the laser's measurement range. And then when it flashes yellow, that means you are at the midpoint of said measurement range. Now one handy function is that these LEDs will function even when the laser is not connected to an outside source. It's very easy for setup. Now as stated before, an Orbit laser will identify on the Orbit network just like any regular standard probe. Now to change the settings on the laser, the most ideal way to do that is to go to Orbit Library Test. Make sure, of course, that you have downloaded the latest Orbit support pack drivers once you have acquired a laser. Click Connect. Go to Network. Now click Ping, and that'll find all the modules on the network. Now here, just like any digital probe, the ID number here matches the serial number for the laser. So now we're going to click that particular module, and as you can see, for lasers they can do all the measurement modes that a standard probe can do, including dynamic, dynamic 2, and read burst. And then if you want to take a reading, you of course click Start Continuous. And there is the raw reading there. Now, if you wish to change the settings, there's actually some features down here. So for example, this is a laser that can sample up to 1 kilohertz. But if you want to lower it to 500 hertz or 250 hertz, you could just click here and click Set. And then the sample rate for the laser will be lower. We're just going to go back to 1 kilohertz. Now there's another feature that you can do through Orbit Library Test as well as do through Orbit Commands, and that is have the laser beam turn on or off. Now if you look at the unit, when I click this box, you will see that the unit is still on, but the laser beam is off. The reason we have this feature is sometimes you will have applications like what you see in the diagram there, where you have two lasers in close proximity and you can potentially have crosstalk, which can cause inaccurate readings. The best procedure for this is to have a procedure where basically one laser turns on first to take a measurement, then turns off, and then the second laser turns on and then takes a measurement and then turns off. For this, you can actually program your software to have that type of sequencing using the command like what you see there. For further information, you can contact your local Solartron representative or refer to page 102 of the Solartron software manual. So that concludes this training session. Again, if you have questions, please contact your local Solartron representative. And again, all training videos, product videos, and applications are loaded onto the Solartron YouTube channel. In addition, you can sign up for the Solartron newsletter, which includes technical information as well as announcements of new products by clicking Contact and filling out the form here. Thank you and have a good day.